Hello, everybody. Let's continue to introduce the TinyRF equip. This lesson, I will introduce the libreVNA, and I will introduce the NI, the currency calibration of SA and SG function for libreVNA. As we all know, the libreVNA also has the signal analyzer and the signal generator function. The theoretic output power of SG is from the negative 40 dBm to 0 dBm, and the ground noise of the SA can reach about negative 100 dBm. So, as you see, I have next one libreVNA. You can see this is a connect diagram, and you can see, okay, this working, and it has the signal generator. So we can see it can, in serial, it can output negative 40 dBm to 0 dBm. And it also has the SA function. So you can see the noise floor is about negative 100 dBm. But the swim time is very slow. So we can normally we can change to 100 kilohertz and it can become quicker. But it still have a lot of limited and slow than the TinySA Ultra. So normally we still use TinySA Ultra as SA. You can see the back. And now I use and also from the frequency increase, the area increase accordingly. Normally, when the frequency come to the 5 gigahertz or to the 6 gigahertz, the tolerance of the power level and the signal analyzer become more and more bigger. So we need to calibration the libreVNA to have a good capability. So now I will introduce how to calibration the libreVNA. Below is a diagram of the correction for libreVNA calibration with TinyRFSG. Now I use the TinyRFSG as a source and the libreVNA as a receiver to calibration the SA function. And this is the calibration interface. Now I will show you the detailed operation. So you can see now it's a connection, and I will use now the libreVNA has not been calibrated. So I try to have a show, and now it's the 5 gigahertz, and the power is negative 20 dBm. Okay. So let's check the libreVNA, and I move the center to 5G 5, and the span I become 1 megahertz. So we can see it got a spur, and this is I add as a marker. It's a maximum. So you can see when I output negative 20 dBm from the TinyRFSG, but the libreVNA receive the power is negative 23.81. So it has about 2 or 3 dBm tolerance. So I need to calibrate. Also, when I use the signal generator, now I close the signal generator, I still change to 5 gigahertz, and this I change to -20 dBm, and I use port 1. So we can see now I connect the cable to the TinySA Ultra. Now I open it. So you can see it already have I have already moved to 5 gig. The number is about -27. When it's not very move it. 25. About 25. So the signal generator is also not very currency. It's about 5 dBm tolerance. So I need to calibrate it.
Okay, this is advertisement time. TinyRF Equip Company. Welcome to our website of TinyRF Equip, which covers and introduces RF test equipment, device, and related RF modules. Our products are mainly used to meet the needs of basic wireless product testing, home radio test amateur, and students' learning needs. Our company is in China, Tianjin. This city is near Beijing. So we try our best to give your RF products with best value for money and high quality. All the world customers can buy our products in Taobao or directly from our company. RF equipment are sometimes very complex, so we can learn from the YouTube video with our good training course. If you buy in our products, we will also give you a best support by WeChat with audio and video. Do not hesitate to directly contact us in Taobao or mobile phone or email. So you can see this is TinyRFEquip.com is our website. Bilibili account, TinyRFEquip. Taobao shop, TinyRFLive. Pay attention, this is TinyRFLive. Email and YouTube, TinyRFEquip Terry. And at present, the products include TinySA, TinySA Ultra, LiteVNA V2, LiteVNA V3, LiteVNA, libreVNA, Detector 2 Near Field Pro, TinyRFSG Training and Consulting. Except the product, we also do some project. Our engineers have experience working in our field. Have undertaken various types of art projects such as new art product development, art signal monitoring, wireless electromagnetic propagation, electron. If you are interested, you can send us email or call us directly. We have some project photos. This is Rhythm Monitoring Project. This is developed by ourselves, and this is wireless electromagnetic propagation. This is a transmission part. This is the receiving part. Okay.
Now I turn off the SG function. Now I come back to the VNA interface. I open the device, and because I use the TinyRFSG to calibration, so I use the libreVNA as a receiver coming tool. The old calibration point I need to add. I add 1 gigahertz, 3 gigahertz, and 5 gigahertz. Oh, no. This is wrong. I need to change this. Delete. Oh, okay, awesome. So, right. 3, 5, Okay. So I add another 3.1 gigahertz, 3 gigahertz, 5 gigahertz. And I use the both point. I need to calibration both ports. If I select this only port 1, I can only calibration port 1, and port 2 date is same to the port 1. So I'm not select this one. I select both ports. And now I will calibration the first 1 gigahertz. So you can see I connect to the TinyRFSG because I think the TinyRFSG is very currency in the lab. What interface? Change to 1 gigahertz 20 on. And then coming to here because the the SG send out about minus 20 dBm, and it also has a cable. I think it's about 1.2 dBm. So here I need to input 2, okay, dBm. Okay, this is the correction factor. It's very small. And this one, and also the second one, has 3 gigahertz. And then it's also about minus 2.2 dBm. Okay, we can see it's a little more correction factor. At 5 gigahertz, this is, I think the cable loss is maybe more than 0.1 dBm. This, okay, is more tolerance. Okay, I have finished the calibration of port 1. Now I connect to port 2. Sorry. Okay, tighten. Now change the TinyRFSG to 0 to 1 gigahertz. And then here it's also minus 2.2. Okay, the tolerance is very small. Here, change to 3. Also minus 2.2. Phase 5 gigahertz. Okay, so minus 0.3. Okay, sorry. Three. Okay, so now has calibration finished calibration the 3 point of the receiver, and we save to the device. Okay, finish. Close. Close this, and then back to this. Open device source calibration. The source calibration is still 1 point before. And now I need to automatic measurement. So we can see if we calibration the receiver, it can calibration the source automatically. Okay. Port 1 connect to port 2. Now I print. Click here. Receiver calibration 4 point. Ready to measure. Auto measure. So we can see 30 megahertz, 1 gigahertz, 3 gigahertz, 5 gigahertz. Okay, it's finished. Save to the device. Save to OK, back. Now I will show you the calibration result. So I come to the spectral analyzer. Now I test the 5. So wait, come to. Oh no. Still need to connection. So we can see now the reading, the peak point reading is minus 20.41. It's very correctly, very accuracy, because normally the signal generator is minus 20. The cable maybe 0.3 dB. So the finish, the libreVNA receive will be minus 20.3 or 4. It's very, very currently. Now I will show you the signal generator after calibration. So I also use the 5G. Now I connect to the TinySA Ultra. So you can see port 1. Okay. So you can see it's a 20.5. It's very accuracy. Very accuracy. So I have successfully calibration the libreVNA both in the SA function and the SG function. Thank you. I close it. Thank you very much.